All right, here we go with lesson 3.3. We're going to talk about CPCTC and circles. CPCTC has to do with triangles, and then circles obviously have to do with circles. So let's talk about the circles first. We haven't talked much about those yet, so let's learn some things. So circles are defined or named by their center point. So if you notice, a lot of circles have a point at the very center, the center of the circle. So we would say, like this big one over here, that's circle P. How would we write it? We would put the center in a circle, so it kind of differentiates it from looking like maybe an O or a 0. So circle P. Kind of like when you would say a triangle, you put the triangle symbol in front. That's our circle symbol right here. And it does have the center in front. So that is a label for circle P. Here we have circle X. So what would that look like? That would be, a bigger circle where X was the center. Or maybe you have here circle Y, where Y is the center. All right, so that's how you name or label or define circles. Now let's look at some vocab that you probably know, but let's just make sure we have a good mathy definition for it. What's the radius of a circle? So if you were to draw in the radius of the circle, you might draw in a line from the center of the circle to the outer edge. And it doesn't matter where it's drawn, so you can see I'm just kind of looking at circle Y up here. All of these are each the radius of the circle. So we will write in, it's the line from the center point to the edge. That is the radius of a circle. And then plural of that is that word. And maybe you could tell me how to pronounce it. Radii, that's my guess. So all radii in one circle will be congruent because it's the same length from the center to anywhere on the edge. So all radii are congruent within one circle. All right, next we have diameter. So what's the diameter? Diameter is going to be the line. Now it's not the radius, so it's not starting at the center and just going to the edge. It's basically the line that goes from one edge to the other edge, but it does have to pass through the center of your circle. So it's the line from one edge through the center, so through the center to the opposite edge. All right, so that's your diameter. I mean, in any of these, you can see if you draw a line through the center from one edge to the other, that's the diameter. Would it make sense for us to say that our diameter is equal to 2 times the radius? So D equals 2R. Look at that mathiness we're coming up with. All right, how about the circumference of a circle? Anyone remember circumference? Circumference is basically, it's like the idea of a perimeter. It's the perimeter of a circle, but perimeter is where you add up all the sides, and a circle doesn't really have sides, so we can't use that definition, so it gets its own word. Perimeter is the distance around the circle. All right, so there's some information on circles for you. Let's move on to the next slide. So now we're going to talk about this whole CPCTC. It will become your friend. You'll probably memorize what it means, or I hope you will. It does actually stand for something, so let's fill it in. CPCTC has to do with triangles, and the first C stands for corresponding. The P stands for parts. So corresponding parts, we throw in an of, we don't say CPCTC, that just gets a little bit too long. Well, so we leave the O out even though it is there. So corresponding parts of, the second C stands for congruent. Are you guys on the edge of your seats wondering what the rest of it stands for? Corresponding parts of congruent, the T is your triangles. And then R, again, that just kind of gets fit in there. We don't say CPCTAC. So just CPCTC, just rolls off your tongue. So corresponding parts of congruent triangles are congruent. So this is a very helpful step when you are proving something about two triangles. Because if your triangles are congruent, then all of the corresponding parts will also be congruent. So here's just a little helpful advice down here. When your diagram has two triangles, you're probably going to follow these steps. First one will be to prove that the triangles are congruent. And that will most likely be with your side, 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 angle, side, angle, side, angle, or angle, angle, side that we did in an earlier lesson. Once you have congruent triangles, that means that all of the corresponding parts are congruent. So next, you could make the conclusion that you can prove that sides or angles are congruent. And the reason, you will just say CPCTC. All right, so there you go.